Hello everyone, my name is Mateusz Pusz and today I'm going to share with you my experiences through the years with my hobby project, which is writing a physical units library. You may have seen my previous talks on the subject. I spoke about this quite a lot, like 4 or 5 years ago. I didn't finish, I'm still working on this and still I'm being far from being done actually. And I'm going to share some experiences with you about the let's say travel, the journey I've made with this library. First of all, this talk has two chapters. I'm going to talk about lessons learned, right? So why the previous design I was speaking about like 3 years ago turned out to not be sufficient. And then we are going to see the new library design and also plenty of practices from modern C++, from C++ 2023, that can be applied to make your code bases better. So first, lessons learned, right? Through the years and from the issues and feedback from our users, we found out some issues in the initial design. I'll be talking about the downcasting facility and the issues that we discovered. I was speaking about this a lot during different talks, so today I will not talk exactly how it works. I will say mostly about the issues about it. I will talk about the things that couldn't be addressed with the previous framework and why user-defined literals are not a good solution for things like quantity library, because this is one of the most common questions I get. Why you're not using UDLs in the modern design? I want to address this as well. And also show you actually how verbose it was to standardize or define and also standardize, because maybe this library at some point will be a part of the C++ standard, how hard it is or how verbose it is to define. All right, so the downcasting facility was or is still an innovative, powerful feature that was the cornerstone of the V1 design. This was, entire library was written around this. And what this facility was able to provide was the fact that if I'm doing some computation on different types, like length and time, for example, in this case, I'm ending up with some derived type from those two, because I'm deriving the speed from the length and time, which means that the framework of the library has to generate some template class that typically is quite large, quite long. In my framework, I was trying to make it as short and terse as possible, but still, it was not the easiest type to read, right? So when I multiply things like the average speed, like provide the 140 kilometers and 2 hours as length and time, I want to get speed, and I want to have this type of speed be as useful as possible, right? And of course, I want this to print like 70 kilometers per hour, because this is exactly what I passed here as arguments, right? So with the downcasting facility, I am able to match a long generated class template that is being generated by the framework of the library, and which is the result of the calculation, with the nicely provided user types like dimension, speed, and kilometer per hour. This is entire type generated from the library, right? So I don't have any long things that provide information. I divided length by time or hours per kilometers per hour. I just get one type that was provided by the user for this specific case. So this is awesome, and it's still awesome in case your library has one-to-one relationship or one-to-one connection between the long type and strong type. Like, for example, imagine having std string being printed in your compile time errors rather than basic string of chars, conchars, stars, allocator of chars, right? This is something that is, well, really verbose and not nice in our compile time errors, right? So the downcasting facility provides a one-to-one relationships between long specialization of generic class template, in my case it was like derived dimension or scale unit, to the nicely named user type. So if you're writing that, you are providing strong user type like dimension speed for derived dimension of dimension speed, meter per second, exponents, and so on. So instead of seeing this long type in the compile time errors, you see dimension speed. And also instead of having this type for derived unit, you see kilometer per hour. In order to make it work, I had to use so-called CRTP idiom, so curiously recurring template parameter idiom, that provides the type of the strong type as the first parameter of the class template, because this is the type that should be deduced, let's say, or converted to by the framework when this specific case is being detected. The issues. It turned out that for many cases in the physical units domain, there is no one-to-one relationship. Those are n-to-1 or n-to-n relationships sometimes. But n-to-1 are the most common, right? For example, I have same dimensions, like energy and torque has exactly the same physical dimension, at least in SI system, which says that the angular dimension, or there's no dimension for angle, right? Angular stuff are just dimensional as quantities. Frequency also is time to -1, right? Also activity is time to -1, and modulation rate is time to -1. So all of them are exactly the same dimension. So there's no one-to-one. If I have time -1 power in my framework, which user type should I use? Right? And also for units, this is the same. Hertz is 1 per second, becquerel is 1 per second, baud is 1 per second, and also 1 per second is a standalone unit by its own in the SI system. You don't want to count number of cars on the highway in hertz or becquerel, right? This is car per second, 1 per second, right? So all of those somehow collided, and this facility was having problems with that. We had compile time errors where two definitions of the same equation, let's say, were found. All right. So I had some hacks as workarounds. For example, baud was an alias unit to hertz, and kilobaud was a prefix alias unit to kilohertz, right? Or I had dim frequency being aliased as dim modulation rate. But this has short legs. You can always find some issues with that, right? For example, when I was working on a modulation rate in the compile time errors, I seen frequency because this is the actual type used by the compiler, right? For most libraries, it may not be something bad, but physical units library, the most important reason for existence of this library is to generate errors. If you're not doing errors that can be detected at compile time, you don't have to use physical units library, just use double, right? So the most important feature of a library like that is to generate errors, and errors should be easy to understand. Having frequency instead of modulation rate is really confusing, right? For many. Also, no matter, for example, if I'm using modulation rate or frequency, I get hertz in the temporary results, if not explicitly converted to baud here, because this was the one that was generated by the framework automatically. And also, as it turned out, when I wanted to measure number of cars per second on the highway, I was not able to see 1 per second at all because it was always hertz. Because the library said, I see 1 per second, it has to be hertz because this is what I know, right? And there are other issues with solutions like that. For example, I have this interface that I shown you, and I'm running include what you use feature. And it says I'm never using anything from the speed header because I'm using here units of length, units of time, and this one is not defined in speed header, it is defined in dimension speed, so just use this one. So I include what you use, and immediately I get those results. This is the quantity being printed, this is the dimension I got. And quantity, a long one, not converted by the framework to the type provided by the user. Why is that? Because the definition with the nicely provided types are not visible in a translation unit, right? Because they were in the previous header. But as include what you use don't know, when you never type those things in your code, they are just the result of computation. Include what you use suggests to remove this header as unuseful and basically suggests some other change. And then this is the result. Also, if you have this code in some header file and have one translation unit that will include the header with the definitions, another one that does not, in both translation units, for the same execution, you get different results, right? This one will provide correct types and correct unit. This one will provide those verbose things, which basically means you have one definition rule violation in your code base. Because this is the same function, the same symbol, the same stuff provided to the linker with two different implementations. Linker will choose one of those. Just to make it straight. This is not something special to this idiom. This is something you have always with any customization points nearly in the standard as well, right? For example, I'm having here some AB header with structure AB, and A has some value, B has some value, and a pointer to A. And I have some streaming operator just to print the values of those. And then in the first translation unit, I can define the swap function for Bs. If I use range swap on those Bs, I have correct result. Maybe not correct, because it just swaps the value from the object, so it only swaps that without A. So it has some custom implementation of swap. In other translation unit, if I will not provide this definition, for example, I forgot to include a header file, it will print something else. Because it will be using range swap that uses this temporary to pass things, and all of the data in such case will be copied. Right? So it's not that downcasting facility is broken, it's the common problem that you may face with any customization point, assuming that you will provide or not the definition for those. For some things like swap, it is harder to, of course, obtain because typically swap should appear just next to the definition of B. So if you have B, you have swap for B, right? In the same header file. If you put it in different header files, please don't, because this is the outcome, right? But if you will decide to put them in different files, then this is a possible issue you may have. Another thing is that users sometimes wanted to provide specific units for some devices. And if this was exactly the unit already predefined, again, collision of types. Also, I wanted to experiment and work more on values, not on types, and I couldn't easily find out how I can recover the name of the value rather than the name of the type with this facility or similar tricks. We started to experiment with compile time vectors, maps, and other things, but well, it was probably really long to compile. So we basically abandoned this thing. So this is about downcasting facility. I think it is still great in case you're having one-to-one relationships between long type and nicely provided type. But in case there is one-to-n or n-to-1, this will not prove for you. Others issues that were not addressed by the framework. First of all, with time, our types got longer. In the beginning, I tried really hard to make them terse, and they are much terser than actually other libraries. I had my talks when I was shown that a type from some libraries on the market, from C++, of course, libraries, the type doesn't fit on a slide with like 20 lines, right? So this is still terse, but probably far from being great. And it basically turned like this when we added support for like radian to degree conversion, which requires floating point ratios, right, of pi number, which made it a bit more complicated. Another issue that we had in the previous library was that we decided, for the sake of the framework, that dimensions are always connected closely to the so-called coherent unit of the dimension. So what is, in a specific system of units, what is the let's say, the official unit to measure that, right? And with this, we had class template here for dimension speed in the ACCU namespace, and we had a concept taking a type here to make it work, and was working with the class template. Another one in the SI that was not a template anymore, so I ended up with two concepts: concept that takes a type and concept that takes a template. And I had to provide two different names for concepts of this, because I cannot create one concept that takes a type and the concept that takes a template as a parameter, because those are different kinds of template parameters that cannot be unified by 3 dots or whatever in the list of parameters. And this actually triggered the P1985 proposal for C++ 26 right now that provides universal template parameter kind, which would allow us to write only one concept for both cases. Also, I was not able to provide standard dimensional analysis that I'm going to show you later on. I think that's last but not least, the units were not composable. So when I started to type something like this to provide angular momentum, I think, then I said, okay, that's enough. I have to find out new framework, right? Because writing this is not fun. This is one thing. Second of all, consider how many similar types, you have to provide for this one quantity of angular momentum for different prefixed units. Like, should I provide gram meter square per second, or maybe I should provide also gram kilometer per second, or maybe I should provide kilogram meter square per hour, and it just multiplies to explosion of different types that I should provide to the user. And if I'll not provide it, there will be some user complaining, but this version that I really need for my production project is not predefined in the library. Right? So this doesn't scale. Oh, yeah, and this one. What does it mean to add a Hertz and bot? They have exactly the same dimension, one per time. But what should be the result, right? My library claimed this is the result before because of those alias units, but probably it is not what you expect, right? So you try to also to model so-called kinds. A kind is a group of types with the same dimension that have some property, some behavior. So you wanted to implement something like length kind, width kind, vertical kinds to be able to say all of those are lengths in different dimension, right? Some libraries on the market try to implement this, and this works quite fine. I can define like quantity of length, width, and height. Those are strong types, tag types. If you've been to Andrea's talk on previously, he talked about tag types, tagging the types to have different meaning, right? So this worked great. But then if you wanted to derive something from this, like horizontal area, vertical area, it didn't compose again. So those were the issues that we found out that were really hard to do or impossible to cover with the previous framework of the library. And now the question, why user-defined literals are not a good solution for things like physical units library? Because this is what everybody expects, because, well, this is what we have for durations in the chrono library, right? So why I'm not supporting that? First of all, user-defined literals work only for literals, right? Surprise. So compile time known values. How many compile time known values do you have in your production code base? I'm not talking about unit tests, right? Majority of the variables you work with are not known at compile time. So in those cases, UDLs are useless. You just spend a lot of time and a lot of effort to define all of them, and they are not useful. Of course, for unit testing, this is great, right? Because in unit testing, you want to test all of the things, and it's so easy to create. Or, for example, if you're having chrono library, right? You have chrono literals, you write 44 seconds and 44 2.second. What do you mean? What do you think? What is the representation type of D1 and D2? What would you expect for those representation times to be in the chrono library? Looks like int and double, right? At least to me. But it's actually int 6040 and long double. Because the user-defined literals always tries to create the longest type possible, because doesn't know exactly what is the value here for specific domain, either floating point or integral domain. And it's basically spread around the code base. If I have like an embedded project that chose to use short for representation, because, well, they do not have much memory, and then I just add or multiply with one literal, immediately the entire type system switches from short to the type that is common for those two. And from that moment, everything is in 64, right? This is another case where UDLs are not the best thing. Also, we found out that many literals, like Farad, Joule, Watt, Kelvin, and many others, are already reserved by compilers. Those are mostly non-standard extensions. So we could say, well, compilers stop doing that, but this breaks users' code, right? So I couldn't, as this was meant to be standardized, I couldn't say like 44, 42 farads or joules. I introduced this _q_ prefix to all of the UDLs, so they do not collide. Of course, for my library, if this was meant only to be library in the outside of the standard, well, the prefix is enough, right? It will not collide with those but at some point we were meant to remove this prefix in case it would be standardized. And then the collisions will happen, so we did this investigation. Another issue with user-defined literals is that in case you have the same unit, like second, in the system of SI and system of CGS, and you want to work with both of them, how do you disambiguate the UDLs? There's no way to say, I want to use SI UDL or CGS UDL. You cannot prefix with the namespace name a UDL. Right? And then also don't compose. If I want to write this angular momentum unit, I have to type it like this. And again, it's a problem of definitions, right? How many prefix units I have to predefine for these UDLs to be useful for the user? I ended up with like hundreds of those, even sometimes for one quantity, if I wanted to have all of the prefixes supported. So UDLs do not compose in such cases. As long as you're having chrono library, or just having a quantity of time and nothing else, lack of composition was not an issue. Right? But here, you want to compose length and time and mass, and then it stops to work. And also, we already seen that, but I want to make it straight. For every single unit like this, as I said, I had like tens of those for one quantity, I have to provide two definitions. One for integral values and one for floating points, which is even more expensive to specify. This is why UDLs are not a good solution for things like physical unit libraries. Actually, this is my slide from CPPCon 2021. I said, well, we analyzed at least 4 different ways to create a quantity, and we still don't know which one is the best one. Please, audience, vote, because we had some online voting. Which one do you like the best? Because we couldn't find the best solution. This was the talk about engineering is about trade-offs, because there was no one clear winner. There was a trade-off, and you have to make a trade-off, find out which one is the best one. And I had some results. From every group I provided this training, I have slightly different results. Actually, I started to play around on the conferences and find out how much I can influence the audience, which one is the best solution, with the same slide behind me. And on CPPCon, I was able to get this result. But for example, on NDC, I was able to actually make another one, being the top priority. Even having exactly the same code base behind me talking about it. And there was like long discussions, of course, before about it. Right? So all of those different ways to create a quantity had their own issues, and we tried to improve as well. And it was quite verbose to standardize systems. Still, the library is quite terse, because all of the libraries, if you are aware of, at least most of them are using macros. Macros to define many different entities for one quantity. To define symbol, to define conversions, to define printing, whatever. A lot of those. With my library, I was having only one line for thing, but there were a lot of things. There was a unit, there was dimension for specific SI, and those literals and aliases. All of this is not needed in the new design. So all of these problems started to pile up on our GitHub issues, in my head, and it was, yeah, I started to look for the solution. And for a long time, I couldn't find the best solution until in September last year, in the middle of the night at 2 AM, I woke up with this, aha, I know how to fix it. Did you have this also in your lifetime sometime? And you know, then you cannot go sleep anymore, right? Because in the morning, you will not remember anything about that. I spent entire night coding, an entire day, next day, and this is how V2 started. And this is still work in progress. I spent thousands of hours already on this working in my free time, and still it's not ready, so I cannot. Yeah, it is on my branch, on my GitHub, but well, it doesn't compile, sorry, yet. Most of the things compiles, but there are some still corner cases from the previous library that I have to port to the new one. Right? Why V2? Even if V2 was not released. I never released V1, by the way. I'm on the version 0.70 officially, and 0.80 was the next one to be released. And I hopefully will release this 0.80 soon. and move to V2 directly. I'm talking about V2 because, well, this is not just an evolutionary step to a new design, to stable design from the previous things. This is totally different. It feels like different product. It breaks all of the user's code. I had some users, the code is being used in production. So I'm really sorry for breaking your code, but hopefully you'll find out that V2 is much better. I could, like Eric Nibbler, create a new repository called mpunits v2, like ranges v3, right? Start a new project. But I decided to stay on the same repository and just drastically improve the version number to make it straight to the users that it is something breaking, but much better in my opinion. Before I will talk about specific details of the framework, I want to share a new style of definitions that you will find a lot in my library and on this next slide. So just to make sure why those things are defined like this, I want to make it explicit here. Users always work with objects that of specific type, but then observe the type representation in a compile time error in this library. To improve the readability of compile time errors and be able to match the implementation with the compile time errors, I actually use the same identifier for the type and for the object. This is allowed by the language. So this is object meter of the type meter, and the object second of the type second. And I can type things like this: quantity meter per second. Right? This is possible only in C++20. This creates a value, and I initialize quantity with a value of some type. What is the type of that? The type of that is quantity of derived unit meter per second, and I pass this instance of it to the quantity. Right? So this is value. This is type name. I wanted those to be exactly the same in order to be easy to match, right? Because if it was value meter second and this was something like meter underscore t second underscore t, it will not look that nice. Right? Also, I'm using the expression templates and extensively in the library. So when I'm typing something like meter per second, I get the type called derived unit meter per second. So again, it's quite easy to understand and really terse compared to the previous solutions. And it's being used for everything, for dimensions, quantities, and magnitudes, and other things that are found in the library as well. You probably know about this, but I just want to make it straight that physical quantities libraries enforce correct code. This is something similar that Andreas was speaking about on the previous talk, right? So if you have average speed, length time, and return speed, there is no way to provide the arguments in different order. This is one of the reasons why we are doing that, right? Also, the scaling of the units is done automatically. And you have dimensional analysis to make sure that the equations here are correct. Because if this is wrong, then speed will not initialize as a runtime type. The return type, not runtime. And of course, there's no runtime overhead as fast or even faster than working with doubles, as we found out before. So this is property of every physical units library in the C++ system. But then you write code like this. How do you like this code? Right? You probably see the issue. Physical units library is to enforce safety, but in case you are dealing with the quantity of the same dimension, like trying to model a box that has 3 dimensions, immediately you are stuck, right? One of the examples my user provided on the GitHub is that when I want to make sure that my truck can fit in the tunnel on the road, I don't want to put the truck sideways, right? When I do calculations. And this is something that I try to address with my V2 framework as well, because I think that's a really important thing to address. So in order to address that, I have to properly address provide proper abstractions for systems. And there are many different systems. Hands up who know about SI, International System of Units, right? Who of you knows about ISQ, International System of Quantities? just for the audience online, everyone nearly knew SI. No one rose hand, no hand was raised for ISQ, right? ISQ is a system of quantities. A system of quantities is the system of, let's say, dimensions without bothering about the units or the values assigned to the quantities, just like all of the things are done on the dimensional level. And ISQ is the official standard specified by ISO 80000 and IS 8000 that specifies hundreds of such quantities. It's the system of quantities based on the 7 base quantities: length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Should sound familiar, right? But this is only about dimensions, not units. And then we have SI that provides units for specific system, SI system, that base actually, and is officially stated in the ISO guide, that it's based on the International System of Quantities. And also in the SI brochure, you can find out that they refer to ISQ as the base for their definitions. And it turns out that none of the libraries I know of on the open source market in any programming language, not only C++, does not model ISQ. It's like was a surprise to see that no one bothers about it, and also it was a surprise for me to discover that there is such a standard, because some time ago I also was not aware about it. Right? There's official standard by ISO, the same as C++ is standardized by ISO, so the same organization specifies a lot of quantities with official equations and names and so on. So what I'm trying to show you on the next slides will be my invented logic to support that, as there is no other solution on the market that does it, at least that I'm aware of. I had to invent this by myself, so if there are any logical issues, maybe something is not clear or looks odd, please let me know, either now or later on through the feedbacks, right? Or from online also as well. It's encouraged to provide some issues on the GitHub, right? Because I may be wrong. I'm trying to find out. This is a lot of design things that I have to do, not only about implementation. So, of course, we have those 7 dimensions for ISQ: length, mass, time, electric current. They're specified exactly the same as you've seen before in an example, right? Dim length, dim mass, and so on. So, you specified only base dimensions in the framework. You never provide the derived ones, so we never care about speed here. We don't want to define those. Just this is enough. Also, I want to say, and I will be saying this repeatedly through the workshop, or the lecture today, that non-type template parameters are awesome. This is something you could not do before C++20. Initialize a template with literal, with a string. This was impossible before. I can even provide a string that has different symbols for Unicode and ASCII text. Right? These things look obvious when you look on this on the slide, but if you imagine that this was impossible like 3 years ago at all, it's a huge change. And it turns out that dimensions are not enough to specify all properties of a quantity. That's why I'm introducing a new abstraction called quantity spec in my framework. Right? There's more than one quantity for the same dimension, as we've seen, right? There are different kinds: frequency, modulation, activity, right? And different quantities of the same kind, like length, width, altitude, distance, radius, wavelength, position vector, that's a vector quantity, right? And yes, quantities may have different character. Those may be scalars, vectors, or tensors, right? And also some quantities are defined in ISQ as non-negative, so you can provide some contract checks as well for those. The ISQ system states explicitly that there is more than one length. Right? This is the tree that is specified in the ISO 80000. We have length, width, thickness, a hierarchy of types. Right? We have height and width being distinct branches in this tree. And so on. In order to define those, I'm using quantity spec, right? To start the tree, like this length, I say this is the quantity of dimension length. So this is where the dimension specified previously is being used to start a new tree of a kind. And then to provide a leaf, I specify basically the correspondence, right? This is width that's defined in terms of length. So it derives from length, let's say, somehow. Maybe not explicitly, but implicitly. And also there are aliases, right? Like here, those are aliases for the same quantity by ACCU system. So this is the main rule that I'm using for the definition, and then I have a long slide with definitions, but I don't want you to read it. Actually, I just want you to see how terse it is to define so many quantities. You just have one line per quantity and that's it, no more, right? So you have all of those specified here for length, you have here specified the same for time, and you can use them robustly to specify what you mean. And with that, quantity kind and quantity point kind type that we had before in the library are not useful anymore because we have dedicated quantities to express those different quantities of the same kind. But then if you have this tree, you have to find out how conversions work, right? What is a conversion in the type system of this tree? So I found that 2 levels are not enough. We need 3 levels. So I named them implicit, explicit, and a cast. So if you have a tree like this, we'll be able to implicitly or explicitly or cast from one place to another, do the conversion. So width and length are not the same, right? Width and height are also not the same. So you cannot compare them. But you can implicitly convert width to length because every width is a length, right? There's no question about it, right? However, not every length is width because it may be height, right? That's why it's not implicitly convertible, but it's explicitly convertible if you so desire, right? Well, height and width, they should not be converted at all because this is for our type safety, right? We don't want to put our track sideways while going to the tunnel, right? This is not how the world goes, right? So they are not implicitly and they are not explicitly convertible, but if you really want to do it, there's an explicit cast to do it. Because sometimes this operation is needed, but it has to be really explicit in your code base that you are doing something wrong. Or something dangerous, maybe not wrong, right? And of course, if you have quantities of different dimension, there is no possibility to convert those at all, right? Time will never convert to length with whatever you try to use. Derived quantities, because right now we spoke only about base quantities, are specified similarly. I provide quantity spec and I specify the equation for this specific quantity, right? Like an area is a power 2 of length, volume is power 3 of length, speed is length by time, velocity is position vector per duration, and so on. And again, NTTPs are awesome, right? All of those are values of classes. Again, not possible before C+20 in the C++ language. And with the fact that my dimensions are just objects and those objects are not templates like they were in V1, I can provide pure dimensional analysis just on the dimensional level or on the quantity level. I can say that area dimension is the same as power 2 of dimension length, or speed dimension is the same as dimension length divided by dimension time, and so on. This is useful by itself. Without values, without units, it may be useful to prove many conditions, to check many things in your libraries. And it's so easy to use. And finally, what should be the result of this following equation, right? We've seen this previously from our V1 library, right? We have Hertz, Becquerel, and Bot. Hertz is unit of frequency, Becquerel is unit of activity, Bot is a unit of modulation rate. All of them are quantities of dimension time to the -1 exponent, right? It's not only my V1 library was, let's say, broken, right? Let's see what Boost has to tell about it. There is no Bot, by the way, in Boost, so I just used 2 of them. This is 2 Hertz. So maybe you want to guess what will be the alternative solution. Maybe the first one is being used. No, it's not. It's also 2 Hertz. Right? Nicked Holthaus units, really popular library in the open source, also allows this to add, but the result is way better. It's 1 per second. So let's say a common unit of those, even though this equation probably should not compile. Trying in other libraries, in other languages, like Pint, from Python. They have both. 3 Hz. Java solution. Java solution provides really nice error log stating that quantity of frequency is not applicable for arguments of quantity activity, so we cannot do add on those, right? I was really amazed actually playing with the Java library in terms of compile time errors. Of course, I'm not amazed by this arithmetics, which is clearly bad. I'm really sorry for Java developers, as they have to play with that. But compile time errors from Java are awesome for this library. We'll probably never able to get there in C++. I will try my best, but probably will never be able to provide such nice compile time errors as Java does. So, what are quantity kinds? ISO 80000 says explicitly that quantities may be grouped together into categories of quantities that are mutually comparable, and says explicitly that mutually comparable quantities are called quantities of the same kind. 2 or more quantities cannot be added or subtracted unless they belong to the same category of comparable quantities. Quantities of the same kind within the given system of quantities have the same quantity dimension. However, quantities with the same dimension are not necessarily of the same kind. Right? And if I only analyze the quantities of time to the exponent -1 in the ACCU, these are all of the quantities that I found with their own trees. They are not connected to each other, that's why there are no branches on my slide, because all of them are separate kinds, even though they are the same dimension. Right? Angular velocity, frequency, rotational frequency, angular frequency, damping coefficient, activity, transfer rate, call intensity, modulation rate. All of them has the same dimension. And probably you don't want to be able to add them, subtract them, or treat them as the same quantity kind. Right? Because your type system, strong type system, will not work correctly. So what I introduced in the library, I introduced something called kind of modifier to a quantity specification. It denotes a family of quantities belonging to the same kind. Such quantity represents any quantity from a kind hierarchy tree. It can be obtained with getKind. So if I call getKind of width, it will be exactly the same as getKind of height, because those are quantities of the same kind, of kind length. Right? So if I do getKind of width, I actually get kind of length is exactly the same result. So kind of length basically specifies this is entire tree, right? Or the root of the tree, depending how you want to look at it. Because quantity of kind of QS is implicitly convertible to any quantity from its tree. So I can say that kind of length is width, kind of length is radius whatsoever, because all of them are kind of length. Quantities of different kinds can be compared or added or subtracted. All right. If you want to specify derived quantities, then you have some issues, because for derived quantities, typically you don't model this tree. You basically provide those equations like mass, length, time, or mass, speed squared by 2 for kinetic energy. Or if you extend this, actually, because it's easy for you to extend this, for potential energy, there is gravitational potential energy and elastic potential energy with their own equations. If you look into those equations, well, they have nothing in common to form a tree, besides having the same dimension. But dimension is not enough to say those are the same kinds, because you don't know if it's, well, modulation rate or frequency. So you need some ways to create a tree, but also to specify those equations that constrain specific quantity. Right? That's why the first stable parameter defines the hierarchy tree, the same as for base dimension as we've seen for length. And if second parameter is provided, it constrains the recipe, the equation, saying that only if you do that, I can convert this implicitly to kinetic energy. And by the way, concepts, not only NTTPs, but concepts also are awesome. Right? Notice that it looks like an overload set of functions, even though this is a class template. Previously, we had to provide different names for different types having different list of arguments. This would be like something like quantity spec with equation, or with whatever, with recipe as a type. Right now, I can use exactly the same and just with different concepts constrain it. Of course, I could enable if class templates before, but it was really inconvenient, as I described on my workshop about concepts on Monday. All right. The result of a quantity equation is not the same as derived quantity, right? Because mass multiplied by length squared divided by time squared is not the same as energy. It doesn't have to be. But those are implicitly convertible. I just want to speed up a bit to not bore you too much if you are not into physical units too much. And explicit conversions are needed if something doesn't match the equation. Users can always extend the library. A library is really easy to extend. You just provide this one line, you have horizontal length. If you specify this line, you have horizontal area. Notice how nicely it is to actually compose the derived quantities of kinds, which was impossible with V1, as I said. Right now we have horizontal area with no cost, right? And of course, a horizontal length is a length, right? Length is not horizontal length by itself, so it's not implicitly convertible. Horizontal area is an area. Area is not horizontal area, so the same property. Length times length is an area. Horizontal length and width is horizontal area as well here, right? All of this is nice. However, length by length doesn't have to be horizontal. It may be vertical, it may be some other area. So it's not implicitly convertible. So the same rules exactly happen as to base quantities. And for now we are done with the new stuff. So let's move on to things that are maybe more obvious. So units, right? SI units is based on ISQ. As I said, this is stated in ISO standard, in SI standard. So in SI system, we know that second is being used to measure time. So we specify this explicitly here with kind ofs. But this is kind of, right? Because I can measure with meter both length, radius, height, and so on. So this is kind of length, not just length, right? That's why there are kind ofs here. And this is specific for SI because in some natural unit systems, well, there's more than one quantity associated with a unit. In those cases, this kind of is not specified for those. But for SI, everything is clear and this is how it works. And then you have derived units that basically are exactly similar in terms of definition to quantity specs, right? You have, again, division of objects, right? And you get other objects and you have those expression templates as a result of those. Everything works nice. And you can even constrain some specific derived units to specific kinds as well. Say, well, radian is not for any dimensionless quantity, it's just for quantities of angles, right? Or hertz should be used only to quantity of frequency, not to end everything that is 1 per second, right? Because we don't want to type hertz for modulation rate, right? So you can constrain it as well to specific kind more closely than just derive the kind from the equation. And again, I already mentioned that NTTPs are awesome, right? Every single parameter of this template is an NTTP, and every single one was not possible to do before C++20. C++20 opens the doors for new exciting abilities here. This is so awesome. Unit symbols. Every unit in the library for the base unit have all of the prefixes from the SI, right? This is how you type them. You can write things like kilo, meter, or just type km, right? However, all of those short things, as we learned on the previous version of the library, tend to collide with user-provided identifiers because you may have something called RM, MM, or whatever in your code base, right? We don't want to import them by default, so the code will be broken or have some ambiguities. That's why they are hidden in underlying namespace that you have to opt in order to have those short identifiers for the longer names. If not, you can still write meter or you can still write kilo, meter. It is fine if you don't want to have shorter stuff. Also, it is important to notice that stud ratio that in the standard library cannot address those. those are either too big or too small to be addressed with stud ratio. Initially there were two, but the next two, like Quecto, Ronto, Rona, Queta, were added, I think, in November last year to the SI standard by the committee. So this is not stud ratio. Stud ratio will not be able to cover those. And finally, because we spoke about the dimensions, quantity specs, we spoke about units, but we didn't tell what a quantity is, right? Quantity, by the ISO standard, again, is a property of phenomenon, body or substance, where the property has a magnitude that can be expressed as a number and a reference. A reference can be a measurement unit. This is exactly what ISO standard says, right? So quantity is just a number and a reference. And this is why it's modeled like this in our library. We have a reference taken by value and a representation type that has to have exactly the same character, at least for now, because we are experimenting with that, as the specification. So it's if the ACCU standard says this is a scalar quantity, we are checking if it's a scalar representation. If it's a vector quantity, we are checking if it's a linear algebra vector, for example. Right? Just to provide additional type safety for all of the operations. And then I expose reference as a value, it's static one, because it's common to all of the quantities of the same type. And then I have a number. And this is all, that's a quantity, because quantity, by the definition, is a reference and a number. Right? But notice that it sucks. This sucks. I have member being public, right? This is a bad design. But this is unfortunately the official definition for so-called structural types in the standard, and structural types are the types that you can put also as non-type table parameters to templates. And I will show you an example, if we have enough time, where I want to put quantity as a template parameter to another template. And that's why my number has to be public. I hope that in the future standards, like C+26 or 29, we are going to fix that limitation of structural types. And of course I have getters for number. I have getters for the R value to move the thing, because sometimes a presentation type is not just fundamental. It might be some non-trivial type, so move semantics is useful. And for const, I'm returning the const. I don't have the fourth one, because I don't want anyone to be able to mutate my underlying value through the L value reference, right? Just get the name, store the reference, and mutate the value inside. It's not something I would like to expose. And I have number in, which is a great suggestion by the community to my project, stating that, well, we don't know exactly what we are returning here, because it may be some intermediate representation type. This always is exactly what user expects. If in case you want to print it or pass it to some, let's say, non-type safe library in the underlying framework. Right? And again, see how many concepts are here to constrain stuff. Concepts are really, really great. All right, so how we can create a quantity? You can either create this by definition, right? You can specify either a unit as a reference, so SI meter or its symbol. Both of them are fine. You can also do multiply syntax that we use for the initialization. So this will create a quantity with the presentation type of double. This will create int, and this is again using symbols. Of course, for symbols you have to do this using namespace unit symbols, right? Because this is opt-in. Or you can have mixed, right? So both of them. And as the construction is implicit, you can use either copy initialization or direct initialization or the copy initialization to be exact with showing exact entities. And then, of course, you can do conversions. Conversions are implicit if they are safe, not truncating. Then you are fine. You can pass kilometers to meters, everything works fine, and as expected. And this is how you construct quantities. If you know my previous library or different libraries or stud chrono duration, you know that you can also create duration, for example, from row number. But I would like to say why it's not a good idea. explicit in the standard is not explicit enough. For example, I have a structure X where I store stud vector of stud chrono milliseconds today, right? So I have then X, I have vector, I do m place back 42. Because duration is explicitly constructable from the value 42. And m place back is doing explicit construction under the hood of vector. But then tomorrow someone refactors the code base. Right? And as everything compiles fine, then this initialization is never changed. This is source of confusion and errors. That's why we decided to not allow this initialization in our library anymore. It was allowed in V1, but in V2 we are not going to provide this one. We always have to provide a unit. Right, but I talk about quantities, I talk about units, but I also spent like 15 minutes talking about quantity spec, and we didn't use them until now in our quantity. So what about the quantity spec? If you will actually remember, meter and second were defined in terms of kind of length, kind of time, because they were able to measure any quantity from the tree. Right? And actually, if I do 42 times meter and do check quantity spec, it will be exactly kind of ISQ length. If I will do 60 times kilometer per hour dot quantity spec, it will be kind of ISQ length derived by time, not speed, because it's not speed still, right? So quantity is defined only in terms of a unit. Model a quantity of a kind associated with such unit. If you want to be more type safe, you opt in by explicitly stating the quantity spec and then unit. This is height in meters. This is speed in kilometers per hour. And then quantity spec is exactly height or speed as you requested. Or you can also do conversion of this quantity of kind length to height. Or the quantity of kind length per time to speed, because this is implicitly convertible. Right? So you get height and speed from this as well. Those both syntaxes are somehow providing similar results, but have a bit different meaning. This creates the quantity right away of this quantity. This creates a kind of quantity, right? And then converts it to a specific type. But the result is exactly the same. And now, you may wonder, how does it work? How does it work without curiously recurring template parameter idiom that we had to use before, right? I have height. My height is just this one line of definition, quantity spec of length height. There are no member functions inside. So if I'm doing ISQ height of meters, this is square operator, right? Bracket operator, array operator, called on height on this object. How am I getting ISQ height as a resulting type? It is not specified here. This one doesn't know about height. And there's no CRTP being used to pass height to a base class. Any ideas how to make it work? There's a new C++23 feature, probably the biggest feature of this language, called deducing this. Right? With deducing this, you basically write quantity spec template. It derives from the quantity provided, but that's not important here. This is the type being used here, right, as a base class. And then I'm writing function called array operator, stating that this parameter of this function will be deduced from the template. And if I initialize it with height here, I get height, not quantity spec of length. Right? And I could put it here as self to the first parameter of reference. Because this is the object on which this operator is being called. And I'm calling this on an object of height. And the same for the parenthesis operator, right? For the call operator, to have the other line working fine, this is exactly the same plantation. This is how you can make much better designs without CRTP or forcing the user. Well, by the way, for every single definition in 300 quantities of ACCU, you have to provide indexing operator for the user to provide strong type. Right? Just one line is needed to specify it, and it works. During my talk on this conference 4 years ago, I provided this slide. What is basically physical units library about? This is about dimensional analysis, right? That power is energy by time. And, well, power is not just watts. It's joule per second, it's Newton meters per second, and so on. I provided this 4 years ago, but until now, it was actually not possible to do this in my library. Exactly, I mean, one by one, what is on the slide. Now I can do it, right? I can check that power dimension is exactly the same as energy dimension divided by time dimension. So exactly this equation can be checked. I can also say I have quantity of ACCU power in watts. That's basically some initialized value from energy divided by second, by time, right? And I can say I have Q2, that is Q1 casted to joule per second, Q3 casted to Newton meters per second, and so on. So I can choose easily which representation type, which unit I want to use for this quantity, because all of them are actually the same units by the definition of SI. So I'm not bound to watts if I decide that joule per second is a better thing, for example, output on the console. All of this then provides, of course, correct results, but this is not exactly the same as on my previous slide, right? Because this is a bit different syntax. This was using dot, this was using s to -3. So with new library, I have additional possible formatters that actually I can get on the unit, and I can say that I'm using dot as a separator, and for some things I don't want to use solidus. Just -3, right? Or divided by 3. You have full control how you want to print your units. Yes, question?
How does it work with this brackets in the second box?
How does it work, this one? With the brackets, this is the question, right? This is just another array operator inside of the quantity type. If the unit is implicitly convertible, and implicitly convertible is when it doesn't truncate, then you can always convert the unit, not only to exactly the same, but also to the scaled version of those if needed, assuming that the value will not be truncated. So this is just an array operator inside of the quantity. But it looks like we tend to write all of this in our notebooks like I did it like 30 years ago in school, right? Time in seconds, length in meters. This is how you type it by hand. So this is quite nice syntax. And I'm probably proud to say that I was probably the first library that introduced this syntax to the domain, because I didn't see this anywhere for now. Right? By the way, I added those 2 slides on the Andreas talk before the next 2 slides, because I think that it's good to mention how actually you can write things like that easily. Andreas talked about the aggregate initializers. And this is how actually I achieved that easily to provide all of this configuration stuff, right? Because I have plenty of things that I can configure here. I have 3 orthogonal things: encoding, solidus, separator. Encoding can be Unicode, ASCII, or default. And Unicode is default, right? Solidus can be written in 3 different cases. Separator can be also either dot or space, right? So having this as a list of arguments to a function will be a long list, and it will be really hard to reason about. You have to, you may provide some defaults, but then if you want to change the last one, you will have to provide other anyway, right? Because this is how functions works with the long list of arguments. If they're defaulted, if you want to specify the last one, you cannot depend on the defaults. You have just to type them in your code. So this is how you can use it. You can provide a structure with the defaults for all of the options and provide it as a second parameter to a function called unit symbol and just default construct it. So when the user writes unit symbol for this unit, it will just have this result, and you don't have to pass anything because it uses default formatting. But then you may say, I want to change only separator to dot and leave the other 2 defaults. and you have dot. And according to ASCII, all right. Solidus, always, all right. Yes, and all of the options can be specified with leaving other defaults. This is a nice trick. Also, only possible with C++20. Right? So if you have something like this, it may be really useful to you. Also, notice, this returns basic string. And I'm doing static asserts to check the result. Starting from C++20, string and vector are context friendly. Actually, in my code bases, I have thousands of static asserts. I don't use any framework for things other than FMT. Only FMT is using catch2 in my library because, well, FMT, at least for now, doesn't work at compile time. Maybe at some point it will start, but not now. But all other things are just static assets in my library, thousands of them. This is so useful, first of all, to check if your code actually can work at compile time. Second of all, I always say that if I cannot compile my code, I cannot ship it. Right? It's easy. With unit tests at runtime, you have to always remember to run them after you compile stuff. This doesn't compile when it doesn't work. It's so much better. All right, so quantity arithmetics. As ISO 80000 says, mutually comparable quantities are called quantities of the same kind. Two or more quantities cannot be added or subtracted unless they belong to the same kind. So this is exactly what you can do with this library. It may first look for you like violating type safety, but I thought about it many days, and I assure you it has some sense. Right? You can compare if width and height is exactly the same length. It is allowed to compare those. And this is exactly what ISO says. Those are quantities of the same kind that should be able to compare, add, and subtract. So also you can add and subtract width and height. It is possible. But now what should be the resulting type? The resulting type, of course, the value will be 2 meters, but what is the type? The type is ISQ length. Not width, not time, it's just some length, right? For example, imagine trying to calculate how much wrapping paper you need to pack a box for Christmas, right? It's 2 times width, 2 times height, right? Plus some margin. It's the length of the paper, not width, height of the box, right? For such use cases, it is good to provide such features without having the user to cast everything to specific type, right? So this was about arithmetics. What about conversions? Right? Value preserving conversions are implicit. So I'm having here 5 kilometers, and I can convert this to meters for printing. Kilometers to meters is always non-tricantic, even for integers, right? So I assume it is implicit. Those are the rules inherited from the chrono duration, by the way. Or, of course, I can also construct quantity in meters from kilometers implicitly. It is also fine. Truncating conversions are provided with value cast, because I'm trying to cast double of 2.5 to an integer. It truncates the value. So I need to put a cast only, right? I cannot do this implicitly. The same if I want to convert this number of meters to a kilometer. I will truncate the value. Implicit conversion doesn't work. I have to value cast it explicitly to specific value. Right? So this is about the values. What about the types? Right? Every height is a length. So you can assign height to length. So if you have a function expecting a length, you can always pass height there and it's fine. And however, the other way around is not possible, right? If you have length and then another one is a height, you cannot just implicitly assign it. So you have to use this syntax, as we've seen before, to convert explicitly to height our quantity 1. So to downcast through the tree, right? And sometimes you may want to actually use width as a height, and then you need this quantity cast that says I'm changing the type of the quantity in an unsafe way. I said it's sometimes useful, but should be clearly visible as a third level of conversions that you're doing something strange. having the implicit conversions like this allows me to make the initialization of an array really terse, like this one. Right? I'm trying to initialize position vector in meters for an array of how many? 10 elements here. If I didn't have an implicit conversion from the kind to position vector, I would have to spell it here everywhere, position vector, position vector, position vector for every single element in the array. This happens always when you have explicit constructors. You have to explicitly tell what is the type here. I tried it, but it was so verbose to specify things like this or like here that has position vector, velocity, acceleration. If I have to repeat this information here, again, it will be again so verbose. So for those cases, implicit conversions are really useful when you have aggregates, because explicit conversion for single element doesn't hurt. Right? It's good to be explicit for one element, but in case of aggregates like this for 3 different quantities or an array for 10 different entities, you don't want to repeat yourself 10 times with exactly the same type. And this is the example where actually you want to do quantity cast, so the explicit conversion. Right? I have spherical distance taking position from position 2. This is some GPS coordinate. I have Earth radius to be radius in kilometers. I do some calculations using Haversine formula to calculate central angle. And then I'm converting Earth radius multiplied by central angle to be the distance. So radius to distance, right, on the sphere of Earth. You have to be able to do such quantities, such operations. That's why quantity cast sometimes is useful to totally change the type. By the way, notice this thing. This bothers me, right? My quantity is using angular measure from the ACCU system. And I have to explicitly do using namespace or using specific functions from the ACCU namespace here. But you may wonder why I have to do it. There is an ADL. ADL should find this ACCU namespace for us, calling sign, at least, right? So why does it work? It turns out that the C++ standard says in the basic lookup argdep chapter that for each argument, a T set of 0 or more associated namespaces are considered for lookup, right? And the rules are as follows. The parameter T namespace, the namespace set basically to be checked for the lookup, are determined in the following way. If we have class template specialization, then namespaces associated with types of template arguments provided for template type parameters only are being searched for the identifier. And also namespaces for template parameters are being searched, but this is not the case here. And there is also explicit note in the standard saying that non-type template arguments do not contribute to the set of associated namespaces, which really sucks. Oh, okay. I think I lost one slide or not. I thought I have one more. Okay. Moving on. Why I have this one? I will maybe show you this. I thought I have. Maybe I have some slide later on. Let's see. Basically, why I'm doing that? Because I could basically put sign cos not in ACCU namespace, but I could put it in my physical units library namespace right away. So it will be found through the quantity type, right? Not through the ACCU. So why I'm doing sine and cosine for ACCU namespace explicitly, not for entire units library. And this is the reason, basically, here, Paul Quincy and other basically engineers and people involved in the domain of physical units libraries argue that an angle should not be dimensionless quantity at all. Angle should be a strong quantity in the SI and in the ACCU as well. There are official documents on metrologia and some letters to the SI committee proposing changing the dimensionless status of radian and steradian within the SI. So the radian right now is a unit of a dimensionless quantity, but there is a lot of interest to make it a strong dimension, right? So I have not only ISQ system, I also have an angular system where I'm saying that there is a dimension for an angle. And I have angle being a quantity spec of this dimension. And I have solid angle being the squared angle and so on. Right? And the radian, then is the kind of the angle, not dimensionless quantity. And I have ISQ angle basically that uses that as well to measure things in ISQ system with the strong angular types that basically Paul Quincy helped me because I contacted him in establishing the correct equations for ISQ. So I ended up with two namespaces. I ended up with ISQ and angular. And I have sine and Arcus sine for both. Well, in theory, I could put all of the signs in the same namespace because they would be found through the overall resolution because those are different types. I'm using here the quantity of angle from angular namespace, and here I'm using quantity of angular measure from ISQ namespace. So in theory, signs would be resolved correctly, but there's no way to actually resolve Arcus signs based on the quantity because Arcus signs basically takes a scalar as an input and provides an angle as an output. And you cannot overload on the return types, just on the arguments, right? So I have to have two different namespaces to separate those. Right? Because this is the issue here. So AD rules are incomplete in the language right now. Maybe it was fine before C+20 when you could put things like enums and integers mostly. In those cases, maybe the namespaces were not that important. But right now, with C+20, as I've shown you, we have plenty of different exciting possibilities, not only in physical units library, because you can use NTTPs everywhere right now. And not being able to search for functions based on this argument is a really bad issue, in my opinion, right? So I can write this one as I'm writing right now, which is a really nice syntax and usability, but ADL doesn't use SI namespace for lookup. Or I can write this one, which sucks to use. But then ADL will work as expected. Right? C++ is the language, then we often cannot have nice things, right? We cannot have those things. At least I think so. I will try, but, well, it's a breaking change. Even before C+20, if you had a structure X in some namespace my and a numerator in the namespace my, right now, calling function foo with my enumerator value or my pointer to X that was valid before C+20 may change the function being found for those cases. If you provided this rule in the standard. So it's a breaking change. I don't expect that there are many things that will be broken, but some code may change the behavior. We'll be doing some investigations, but I think, well, that we are stuck. We cannot change it. So ADL doesn't work. Unless we'll have some epochs, as Vittorio said out on the panel, right? Then we may say that this is an epoch, and in the epoch, ADL rules are a bit different. Then it will be better. All right, so just to slowly start summarizing and maybe showing you some more features. Now I can write this box easily, having strong type arguments. As you've seen before, it was an issue for every library on the market, right? And I have easily horizontal length, height, and so on. I can initialize it with either first line, or I say, well, I don't care about the types. Or I want to care about the types, I can either use this syntax or this syntax, and in these cases, I cannot reorder arguments. I know that it may look a bit unsafe to allow the first syntax here, but, well, we need these implicit conversions in order to be able to provide other features in the library. So it is up to the users to specify, I don't want to care about type safety in the specific cases. I know that I'm doing this right. I want to write a short code like this one, and this works fine. But if I want to be explicit about the types, I can do it, and then every error will be found at compile time. So basic users have control, either to be verbose and explicit, or short and potentially a bit unsafe. You can also write the generic interfaces because those require specific quantity if in meters, for example, right? You can write generic interfaces using templates and concepts, saying this first argument will be quantity of length, quantity of time, right? Constraining the auto type here. And the result will be the quantity of speed. And I'm just taking those, dividing, converting to ACCU speed explicitly, so it is a correct quantity spec, and returning that to the user. And then if I write average speed for kilometers, for miles, or even altitude and duration, it will work fine, right? Because, well, this is speed, the result of dividing altitude and the duration. And of course I can print that. I can print that and have correct unit for all of the cases. C++23, right? Printing with print line and print. Of course, every physical units library should work with custom representation types. For example, here I have a type for measurements. Measurements that take 2 parameters in the constructor and sets to members, a value and the uncertainty of the measurement of this value. And every library should be able to work with those, not just with doubles or ints, right? So I can write something like measurement. I have 123 meters, and well, my measurement is possibly wrong with 1 meter accuracy. If I multiply this type by 10, also not only the value is changed, but also the error is changed, right? And you can make easily calculations like this. Or maybe a bit advanced or complicated stuff where we're having measurement of the acceleration with this precision and some measurement of time with this precision. Multiplying those will also return things like this in meters per second here, or if you cast it to kilometers per hour, in kilometers per hour. Another possibility, so talking about the representation types provided by the user. What is the result of LA vector times meter? What would you expect? Linear algebra library tries really hard, right? And checks if int can be, because this is the representation type of those elements, can be multiplied with m. If it is, then it tries to create linear algebra vector of quantity of meters, right? Because it wants to multiply 1 times m, 2 times m, 3 times m. So the result will be a vector of quantities. And my library, on the other hand, treats this as a scalar, like measurement or integer, and says I want to create a quantity of meters with this representation type. Quantity of meter with LA vector of 3 elements of int. And this is where this syntax has some shortcomings because we have collision of operators, right? This is why I provided also make quantity factorial function to create a quantity from a raw value in case of such collision happens. And of course, if reasonable, you can provide a dedicated operator that says explicitly if I'm dealing with LA vector and the reference as the right-hand side argument, I just want to call make quantity, and then you are basically resolving the ambiguity with dedicated use case. All right? So this is about the custom representation types, but there is one more thing that I would like to point here, is that when I'm having this measurement type I shown you that has value and uncertainty, I'm taking the value type as an argument and an error. So I'm passing value easily right now with std_move, but an error will be ABS of error. On my training I said that the constructor should have, if possible, only empty body. You should always initialize everything in the constructor initializer list. But well, I cannot do using namespace std in the constructor initializer list. Right? It sucks. Another use case. When I'm running ABS for a quantity, I have to do, of course, using std_abs because this is how we deal with customization points. Everyone should know it, right? Or we have niblois that do it for us. But then if I want to constrain it with my concepts, I have to check for both cases. Because either a user provided ABS for some measurement type, or it is a fundamental type, so stud ABS should work. And I always have to take care about two of them, which again bothers me. And we are getting more and more wrappers for mathematical types. Not only things like measurement, but like safe integers, fixed point precision, fixed precision stuff, and many other things are coming to the market right now. There will be more and more mathematical-like types, numeric-like types, and they will have exactly the same problems. So maybe we should start thinking about making CPOs for every math function in the library. So those can opt in and provide customization for specific use cases. Right? So we don't have to do using std ABS or using std swap. We don't want to write using std swap in our code. That's why we have swap being CPO, right? In the ranges library. With the numeric types, you have to write using stud ABS, using stud sign and other things all the time, and then having CPOs for those is a good idea. Last but not least, the affine space. Right? We are not talking only about quantities, we are talking about points. As in Chrono, you are having duration and time point. Those define and model affine spaces. Right? So I'm having here some mean sea level is an absolute point origin of height, called mean sea level. And I can create quantity point of height, mean sea level, and this will be the ground level of Zurich Airport. And this is the height from relative to mean sea level of my hometown, Gdańsk airport. And then okay, I can create another quantity point saying this is the altitude basically above the airport, right? For Zurich and Gdańsk, and use those two as the origins for this quantity point. And notice that I'm passing a quantity point type value, this is a value, to another quantity point. And this is, as I said, I will show you an example where structural types are useful. Because quantity point is a structural type, and for it to be a structural type, it has to store a quantity inside as well. And this quantity has to be structural type as well. So making a quantity a structural type allows me to pass it here as a template parameter value to define those. And then I can check all of the things, how those are relative to each other, what is the absolute altitude, or what is the difference between those two basically altitudes, and so on. I think this is the last slide before summary. Faster than light speed constants. We have standards. We have some standard constants, like standard gravity, right? G, everyone knows G probably, right? We learned about this in school. So I have here some example from one of my examples in the library. I'm having field wave that returns wave, because wave is not a mass, it's a force, right? Multiplying mass times G. And I have field level that has height, measured mass, G, divided by field length. So I'm multiplying by G and dividing by G to get field length. And if you want to take those values and print them, ideally, I would not like to do this because it takes runtime. It also breaks precision because this is not an integral value. And actually, it is possible, and I implemented this in my library. So if you take the result of field weight right away here, field weight is being printed here directly or in newtons, you'll find out that by default, it is not printed in newtons, it is printed, because I returned this as a concept rather than correct type, it is printed in G kilograms. So the constant is being put to the type rather than to the value, and the value is just 100. There is no floating point precision involved at all, even though it encodes G acceleration. And then if I divide it by field level, this, let's say, unit just goes away and never was used for calculation. Improves performance of runtime, improves precision of the final result. So to summarize, no more downcasting facility, right? And CRTP idiom. We are not having those abstractions anymore. Exponent, prefix, quantity kind, quantity point. We simplified the type system. We have one named unit and one quantity spec to rule them all, thanks to overload resolution like concept stuff. Much terser system definitions, ACCU dimensions are not templates anymore, so we can do pure dimensional analysis. Better, composable units. Consistent NTTP usage improves readability and usability, as you've seen. Expression templates improve readability of types at compile time and in compile time errors and in the debugger. Pure dimensional analysis, right? Robust quantity creation helpers. We have only one right now with this multiply syntax, and it works great. Quantity specs to improve quantity definitions. Support for all ACCU quantities, proper quantity kind support that are composable as well. Faster than lightning constant, right? They just optimize away if possible, and so much more. And well, we are actually out of time right now, but I'm of course eager to take questions. But for the recording, thank you very much. If you have any questions, we'd like to try this library. Right now it's on the branch, but I hope it will be on the main line soon. Right? Please provide feedback on our repo or contact me directly. I will be really happy to answer those and maybe to describe some features if something is not clear. So yeah, this is my talk. Thank you.